दूध पतला होते तो आप थोड़ा सही दो। गाय का दूध ऐसे रहता है। बहुत पतला गाय का दूध हमारे इधर नहीं मिलता है। कहाँ? जहाँ रहते हैं। कहाँ रहते हैं? थोड़ा सही कर दो भैया। अरे हम गाय का भाई बताइए मिक्स तो नहीं करते हो आप? आप हम पूरे देता हूँ। हैं? सामने आ देता हूँ। नहीं मतलब मैं दही जमाती हूँ ना तो वो दही में वो एकदम 5 रुपये है। यहाँ गाय का दूध पीने कम आता है। यहाँ दही नहीं होता। यहाँ क्या खिलाते हैं? थोड़ा सा खिलाते हैं कुछ मिलता है। क्यों आज बच्चे नहीं आए?
रिकॉर्डिंग चल रही है।
पढ़ा नहीं रहे।
अब चाहे तुम घूमो पीछे तो आओगे वहाँ। So enough time for waiting. So today we will talk about second week assignment as well as some brush up which is you have been seen in the videos of week 3. So in the second week assignment our first question comes that what is the refraction matrix for a thin convex lens of radii of curvature r1 and r2 and having refractive index n is. So as we know that the refraction matrix of a thin lens is described as 1 and 1 minus f 0 and 1. Okay, so this is our matrix of thin lens minus 1 by f. Okay, so then what is the relation between focal length and the radius of curvature r1 and r2? So as we know, this is 1 by f is equal to n minus 1 minus r1 minus 1 upon r2. Okay, so we can put this relation into the equation 1 and we will get that the refraction matrix for the thin convex lens of radii of curvature r1 and r2 is equal to 1, and in place of this I will write 1 minus 1 upon r1 minus 1 upon r2 and 0 and 1. Okay, so our answer will be this one for the question refraction matrix for a thin convex lens of radii of curvature r1 and r2 and having refractive index n. Okay, so this is our question first. Similarly, the question number 2. We have question number 2 is system matrix for an optical system matrix for an optical system is given by 0.5, 0.45, 0 and 2. Okay, so magnification of this optical system will be, we have to find magnification. Okay, so as we know that the any optical system, the refractive index, then what is the magnification? So the this term is shows the magnification. Okay, so the answer of this will be magnification is 2. Okay, for this matrix system, this term denotes the magnification. Okay, so magnification will be 2. Okay, so similarly question number 3. Question 3 is a ray travels 20 meter in a homogeneous medium of refractive index 1.45. Okay, the corresponding system matrix. Okay, so what will be the system matrix? So how will we find the system matrix? So we know that the matrix of the homogeneous medium of distance d is 1 1 0, and what is this here, d or 2d? There is a d. If system travels, ray travel d in the system. Okay, so what will be the d? If the refractive index is 1.45, then d is, this will be d by n, so that is 20 by 1.45. What will be the answer? So we find the matrix if system reflects in d distance. Okay, so you can find the solution, right? So similarly, we come to the question number 4. So question 4 is given that system matrix for an optical system is given by 1 1 0 and minus 0.45. So the focal length of the optical system will be, we need focal length of the optical system. So we know that the matrix is given like 1 1 0 and 1 by f, sorry, minus 1 by f. So this will be 1 by f is equal to 0.45. So f will be 1 by 0.45. Okay, can you calculate? Now what is the So next question is, again this, consider a system of coaxially placed two thin convex lanes. Consider a system of two coaxially placed thin lanes. Okay, thin lanes of focal length is 5 centimeter and 8 centimeter. Okay, so sorry, 5 centimeter and 8 centimeter, the lanes are separated by 12 centimeter, and these given 12 centimeter, the focal length of the system will be, तो हमें combined focal length we have to find out. So there are two ways. You can just find the combined transfer matrix and then compare the systems this focal length wala term, or you can put the direct formula, that is 1 by f1 plus 1 by f2 minus d by f1 f2. That term only comes here. I think we solved the last class this formula, right? The transfer matrix of two separated thin lanes. Hello.
Yes, sir.
So what will be the answer?
So whether it is minus d by f1 f2 or plus f?
I thought this is minus d by f1 f2. There should be. Hello, am I audible? Who is this HMS SIT?
Yes, it is audible.
Okay. So the question is, what is the focal length of thick lens? We derived with the transfer matrix in the last tutorial class. So can you find this or I have to solve?
I know this, it is solved.
Okay. So we know that the thick lens, whatever will be the thick lens, this will be like that. So we consider this thickness is T. Okay. So the refractive index is N, right? And this is also N, and this is also N, and outside is 1. So this is a thin lens, right? This is also thin lens. So thin lens refractive index focal length is f is equal to n minus 1 divided by r. So from this side the matrix will be 1 0 1 minus 1 by f, which is this one, or we can say f1 because this is r1, and second thing will be 1 1 0 and t by n. Okay, and there is again 1 minus 1 by f2 and 0 and 1. Okay, so we can just multiply these terms, so it will be 1 minus 1 by f1 and t by f1n, and this will be 0 and minus 1 by f1. Okay, and this will be 0 and this will be t by n, and this is 0 and this is 1. So this will be 1 minus 1 by f1n, and this will be minus 1 by f2 plus t by n f1 f2. Okay, and plus minus 1 by f1, right? And so this is mainly our focal length term. So then we can consider 1 by f minus 1 by f is equal to minus 1 by f1 plus 1 by f2 minus t T, Y and F1, F2, right? So this 1YF is equal to n minus 1 yr1 plus n minus 1 yr2 plus T and this will be n minus 1 ka whole square r1 and r2. Okay, so this will be something like 1YF is equal to n minus 1 1yr1 plus 1yr2 and plus T n minus 1 whole square and r1 r2. Okay, so in this option this is one of the option that will be correct. Oh sorry, this is minus. Actually this r2 will be 1 minus n, so that's why here will be 1 minus n if we consider minus 1 by n. Do you find the same answer? So do you find the same answer or not? One second, I have to plug my laptop. Now next question number 8 is, what is the determinant of a system matrix is? So we always know that whatever the matrix comes here of any optical system, the determinant of that matrix is 1. Okay, so this you can remember कि whatever matrix system will come, that will be unity, because this is not a gain medium. Okay, just a transfer matrix. So we will not any enhancement or something, just convert from one to the another thing. So the next question is similar way, is the focal length of a combination of two thin lenses of focal length f1 and f2 which are separated by a distance d will be given by. So I already have mentioned in the earlier, I think in that question, numerical question, the formula comes like that only. And how will you find this formula?
कैमरा चल रहा है क्या? तो तैयारी तो कर रही थी मैं।
ऑडियो भी चल रहा है।
तो क्या पता है ना सारी मूवी छोड़ेगी। ये खाना क्या बनाऊं बताओ ना। कुछ नहीं बनाऊंगा।
So this determinant of a system matrix
रात डोसा ले आता
ले आऊंगा।
खा लेना।
8 बज जाने तो उसके बाद मैं करता हूँ जो काम बोलोगे। So we will find the question, the formula for this thing, right?
क्या कर दूँ?
Yes, sir.
Okay. So the nodal planes coincides with the unit planes Vn. So nodal plane के बारे में sir have told, right? So in question 10, the nodal plane coincides with the unit planes Vn. So this is the question. So the option are media on either of an optical system have different refractive indices, or media on the either side of an optical system have the same refractive index, or no dependence on the refractive index of the surrounding of the optical plane, or none of these. So in this one the answer will be when the media have the refractive index same from the both side, then only this nodal plane coincides with the unit planes. Okay, so this was the assignment of second week. Now we come to the third week syllabus, whatever sir had taught. So have you seen the videos of third week?
No, sir.
Why you are 1 week behind?
Sorry for that.
Not sorry, it's okay. So okay, then I will tell you something. So in this week, third week, sir have discussed about superposition of waves. Okay, first thing, and the second thing is wavefront concept, and third thing sir have discussed that Huygens principle. Sorry. And fourth thing sir have discussed introduction to polarization. In that one sir have discussed linearly polarized light. Second, third, circularly polarized light, and third thing is elliptical polarized light. So so what thing you want me to cover in these things? I can cover here something, not the fully videos, but little bit I can intro here about these things. What you want me to explain in these things? Because superposition of waves, I think you should know already if you have read in 12th or something. Wavefront concept also you have some idea. Huygens principles you should have some idea. And polarization maybe little bit is difficult thing, but you have idea about all these topics. We will discuss little bit. So what is your understanding about superposition of waves? So let's come to what happens if we addition of two waves of same frequency. Let's see here for the easiest case. For the same frequency, we are considering two waves. So whatever you are solving the differential equation, the equation of wave can be written in the form of E x comma t equal to E0 sine omega t minus kx plus delta. I can say here delta is maybe some initial phase we are considering. Okay, so this is the book which sir have followed, Eigen H, and also the book from Ajay Ghatak, the optics book. So I am also reference from these books only while teaching. So if we have in which E0 has the amplitude, okay, and harmonic distribution propagating along the x-axis. Here is the x-axis, so it is propagating in the x direction, and to separate the space and time parts of the phase, so let us consider this alpha is some x and this delta term, so it will be around minus kx plus delta. Okay, then now we can consider two waves, like one is E1, we can write E01 sine omega t plus alpha 1. Okay, and because we have considered same frequency, then there is only omega, then equation 2 can also be written as sine omega t plus this is something else alpha 2. Okay, so now what is the, if we addition it algebraically, then the resultant will be E1 plus E2. Okay, so how can you write this? So you can write something like E01 sine omega t plus alpha 1 plus E02 sine omega t plus alpha 2. Okay, so how will you add these two?
So we have to expand the sign.
Yes, sine a plus b, and here also sine a plus b. So there will be a long derivation like that. So but if you separate this omega term, okay, so you will have something E01 cos alpha 1. This is written directly the equation letter, so I am writing the same. E02 cos alpha 2, okay, and it is coming sin omega t, okay. Similarly, the second term will come plus E01 sin alpha 1 plus E02 sin alpha 2, and it will come in terms of cos omega t, okay. अगर now I compare this equation to this equation only, then what will be your inference? I am considering that E0 cos alpha equal to E01 cos alpha 1, because this is both cos, so I am considering this as a cos term, okay. E02 cos alpha 2. Similarly, I am considering E0 sin alpha equal to this term, okay. Then you can write this something like E0 cos alpha sin omega t, okay, plus E0 sin alpha cos omega t. So you can write this as a E0 sin omega t plus alpha. Is it so? No. Yeah, this is so. Where now the resultant wave have the amplitude this, okay, amplitude of resultant wave. Similarly, this one will be the phase of resultant wave, or you can say spatial phase, or the omega will be also the same for the same frequency, because we are considering the same omega. You can consider the different frequency also. Then you will start like, here is omega 1, here is omega 2, okay. Then you will proceed, then you will find in one term this is omega 1 plus omega 2, and in another term there will be omega 1 minus omega 2. So when this omega 1 minus omega 2, then you have heard some concept of beat of waves, beating of the waves. Have you uh, heard this name, beat, in sound waves or somewhere? You should have in 12th, I think, in the last chapter. Maybe now they removed some syllabus also, so I may not remember exactly, but in my time there was some this wave things, phenomena things. So now we are considering the amplitude term, okay. So we have to find this E0. So how will you find E0? You just square these two terms and add, then cos square alpha sin square alpha will be 1. Okay, so this will be E0 square, what it will be, E01 cos alpha 1 plus E02 cos alpha 2 whole square plus E01 sin alpha plus E02 sin alpha 2 whole square, okay. So if you open this term, I think you should come up to this term, E1 E01 square plus E02 square plus 2 E01 E02 cos alpha 1 minus alpha 2. You will come like this or not? Most probably you will come to here. Okay.
Okay.
So the physical significance of this equation is like we have two waves of the same frequency and they superimpose at some point, okay, in some special point. So the amplitude of these two depends on the initial phase of these two separated waves. Okay, have you got it? Yeah. So if they are at the same phase, means alpha 1 equal to alpha 2, then this cos 0 equal to 1. That is E0 max. Okay. And when they are out of phase, means the difference is pi, no, sorry. They are at the difference of like alpha 1 minus alpha 2 is equal to some pi by 2 or its multiple, integer multiple, no, odd multiple, okay, either pi by 2, 3 pi by 2, 5 pi by 2, like this. Then this E0 comes to the E0 min, that will be equal to E0 1 square, sorry, I will come it here. This will be E0 1 plus E0 2 का whole square, and when it will be integer multiple of pi you consider, then it will come E0 1, E0 2 का whole square. Okay, are you agree with me? These two cases, in this case and this will be in this case. Am I right?
Yes, sir.
Yeah. So as you read about interference term, so this is our maxima and this is our minima. So that's why we say that for the interference there should be they should be at the same phase. Then there will be interference pattern like Young's double slit you have right now. So here they have same path difference. Then here they are got some pi of then the minima. And if the intensity and the amplitude are same for two separated wave, then this will be completely zero, right? And this will be completely maximum, that is 2E01, something like that, right? So for interference pattern seeing very clearly, you should have the two separated wave of equal amplitude. Okay, so this is some type of superposition of waves are covered in this one. So I just derive some mathematical concept for that one. And the superposition of two or more waves you can also write in the similar way. Here I consider the two waves. Then similarly you can consider here two or three waves and just sum algebraically, and this there will be some cos series and sine series and the resultant of cos series. All these mathematics will come into the phase, and then you can consider the complex phasor method to add all these waves. Okay, so there are some brief of this thing. The addition of wave of the different frequency. So that you want me to drive that thing also. So in that one there are some beats will be there. So like what you will geometrically say. So this is one wave, okay, and this is another wave. So two wave will be coming, right? So whatever there will be some phase or a interface, according to that you will get maximum intensity if they are in same phase initially, and if there are some out of phase, then initially they are out of phase, then the intensity will be minimum. right? So amplitude will be decreased, something like that. The things will happens like that. But in the beat, you will have at the certain points the frequency will vanish. Okay, so like uh, one student is coming here, one student is coming sitting here, one student is sitting here. Okay, so beats will happen at this point, so there will be no frequency. Here there will be no frequency because difference of this omega 1 minus omega 2 equal to 0 at some points. Some points the frequency will be doubled. So something will happens like that. Okay, this will be like somewhere frequency is very high, somewhere frequency is very large, something like that. So this is called something called beat. Okay, so this is in the from the portion of superposition of waves, and then second thing is wavefront concept. So there will be Fourier integral, all these things in the superposition of waves, discrete Fourier transform, and all these things. Then we comes on the polarization thing. Okay. So what is the polarization of light? Do you have some idea? Then just tell me so I can get your input. That's it. So I can tell you little bit further or just from starting I have to tell. So I am waiting for your response.
Vibration of the particles in one direction.
Sorry?
Vibration of particles in a light in one particular direction is called polarization.
And then what is in circularly polarized? Okay, we will come to that point. But you are right in some way that the polarization is, see, the light is the transverse wave, right? So in transverse wave there is one particle which is traveling into this direction, okay, but it vibrates in this direction. Okay, that's why this is the phenomenon of the transverse wave. So particle can vibrate in this direction. So generally we have x, y and z. Okay, so we are considering here that light is propagating in z direction. Okay, so the particle can vibrate in the plane of xy. So particle can vibrate along x direction, in y direction, or somewhere here, somewhere here. So all possible direction the particle can vibrate. So in the nature, unprocessed light, generally it is called unpolarized light. This is of the nature of the same that particle, the light vibrates in the all the direction. Okay, but this is the linear polarized light. Okay, so unpolarized light, the particle of that whatever the photon can vibrate in the all the direction x, y, z or any direction. Then we called it unpolarized light. Okay, so what is the linear polarized light? but in polarized light we restrict the vibration in a particular direction. Okay, so what is the linear polarized light? Now let me consider two orthogonal optical distribution, like one is in x direction, that is we called x, that is propagating in z direction in time t. Then you can write it, see if this is going to x direction, so I consider is I cap. Okay, so this will be E0 x and cos kx minus omega, sorry, kz minus omega t. Similarly you can write one another direction z t, this is only vibrating in z direction, so this will be Ey, and this is cos kz minus omega t. Okay, and now in one direction we are considering some another constant term which is called relative phase. The relative phase is the phase with respect to this one. Okay, either you can say here one constant delta 1 and here one constant delta 2, then you can find the relative phase delta 1 minus delta 2. Okay, but here I am considering the delta only in one equation, and we are considering here the delta 1 is 0 and delta 2 is delta, so the relative phase will be delta. So what happens ki difference between these waves, both of which are traveling in z direction. Okay, so now keeping in mind that from the start that because the phase in the form kz minus omega t, the addition of positive delta term means that cosine function will not attain the same value as the cosine in equation 1. Just like that, this is traveling one wave. Okay, another is traveling wave. If this is 0, okay, so it is traveling with some phase. So I think the another wave will travel this is just for a value. This will be like that. This will be at some point the phase will be lagging from one to another. Okay, so what will be the resultant wave? So this will be the resultant wave will be E vector. Now we are considering as a vector because we are also considering the direction of these waves. Okay, so this E0 z comma t will be I cap E0 x cos kz minus omega t and plus j E0 y cos kz minus omega t plus delta. Okay, now we are considering some specific case 1, this delta is equal to plus or minus pi. Okay, then what will be the case? Then you can write E0 vector z comma t, it is something like I cap E0 x plus j cap E0 y, sorry, pi and minus pi, then this will be minus cos. Okay, so here will be minus, this will be common and this term will be same for both term, something like that, kz minus omega t. Okay, so this wave is again linearly polarized. So this is linearly polarized because this wave is linearly polarized. and this wave is also a linear polarized, because we are saying this amplitude is only in one direction and its amplitude in the only one direction, but here it is also only in one direction, which is the unit vector of that is, if we consider the unit vector of this vibration, the amplitude direction, then it is something like 1 upon E0 x plus E0 y. Am I right? So this is the unit direction, I think. Because unit direction, we can say ki I and Z, this will be only in one direction, right? The resultant. Like one vector is this direction and one vector in this direction. The addition of this vector will be somewhere like this. Okay. So this is something, this I E0x plus minus J E0y, and this is E0x and this is J E0y. Hello? Are you getting my point? Yeah. So now can I ask one question to you? The question is, one wave EY is there, okay, and one is EX. The phase difference between these two is 2 pi. Okay, so what is the resulting wave given by this? So again we will consider the same terminology here and here. Now we are considering the phase is 2 pi. Okay, so in second case, if we consider 2 pi, then this will be plus cos, right? So the resultant will be I E0x plus J E0y, something like that, the amplitude, and this term will be the same. So this will be again a linear polarized light. Okay, so linear polarized light is something that light, the vibration of that light will be only in one direction or in plane, linearly in the plane of propagation. Plane of propagation, you consider, you know what is the plane of propagation? The term plane of propagation is something like that. The light is traveling in this direction, let's say this is Z direction, then the plane which represents X and Y, okay, so this is X and Y, then this is the plane of propagation. So the vibration will be only in this plane of propagation. Like if this one is your plane, so vibration will be in this direction or in this direction or in this direction. Only one direction vibration is allowed in polarized light, or whatever you can say. And if you combine these two waves of different polarization or one linear polarization, the resultant wave will also have the linear polarized light if they have the phase difference of pi. Okay, so this depends on the phase difference between these two waves. Okay, so second term comes circular polarized light. Okay, so now we consider the particular case that we have E0x and E0y both have equal amplitude. Okay, both have equal amplitude, and the phase difference between these two waves we consider pi by 2, then what happens? Can you solve these above equation again and find the resultant wave by adding these two waves? Should I write here? See, Ex we consider in x direction. This will be something like sine kz minus omega t, and Ey will be j cap E0y cos kz minus sine kz minus omega t. Same we are considering sine, and if they have the pi by 2 phase, so let's consider this plus delta, then you will have E0 equal to Ex plus Ey. This will something like I cap E0x sine kz minus omega t plus j cap E0y cos kz minus omega t. Okay. Now consider it is traveling in this direction. Okay. At t equal to 0, the wave is somewhere here. There is some plane. Okay. And this is your x and y. Okay, this is at t equal to, we can say, after some time, you can say this is, or we can say omega t is equal to, this is omega t equal to 0, this is omega t equal to pi by 4, and similarly omega t is equal to pi by 2. Then what will be its vector? So let's say at initial we have E0x is equal to E0y, right? Equal wavelength. Okay. So let's say it will be at some point this one. This is E0x. This is E0y at omega t equal to 0. At after some time, now you can, this is your resultant, right? So sine increase or decrease if time goes in first quadrant. Sine wave is something like this, okay, and cos wave is something like that. Am I right? So like t equal to 0 starts from here, and this is your t equal to pi by 4, right? So at pi by 4, go to pi by 4, the sine has x term, so Ex will increase, right? Ex will increase and Ey will decrease. Let's say it comes till here. So now resultant vector will be this one. Okay. Similarly, after pi by 4, this will be maximum. Okay. So all terms will come like that. So if you say on this axis, initially it was here, then it comes here, then it go to this perpendicular line, this, then it comes here, and this comes here, and next this comes here. So this polarization of the vector with the time will rotate. Okay, rotate like this, and also this is your time axis, so it will rotate like this. Okay, so it is rotating in circularly, so that's why called it circularly polarized with the time. And if you consider this minus t, this is minus t, then it will rotate like this, rotating instead of this. Okay, can you see my expression by I am showing with hand? So on the basis of the rotating of this vectors, rotating with the vectors, we can say two types of wave. One is right hand circularly polarized light, and other one is left hand circularly polarized. Okay, how can you find what is right hand circularly or what is left hand circularly polarized? See, here the time is always consider that light is coming towards you. Okay, this point is towards you. Then if the light is rotating like right hand, then it is right hand circularly polarized. If light is the vector is rotating in this direction, which can be mimicked by your left hand, means left hand circularly polarized. But here I am considering that light is coming towards you. You are seeing light is coming towards you. Then on the basis of that, if the polarization vector is rotating your right hand like this, then it is right hand circularly polarized light. If light is rotating in the left hand across the left hand thing, then it is left hand circularly polarized light. Are you getting this point? So on the basis of this polarization vector, you can say this is circularly polarized light or this is right hand circularly polarized light. See, when the circle is formed, the electric vector what we are considering is Ex and Ey. These are equal. Okay, so it's this one axis and two axis are equal. That's why it is circle. Now, if we consider the case where Ex is not equal to Ey, in that case there will be Ex less. Sorry, not Ex, E0x. The amplitude of the wave which we are combining are not equal amplitude. Okay, less than E0 by. Then this will be something like that. This will be your Ex and this will be your Ey. Then in this case, this is called elliptical polarized light. Okay. Yeah. So circularly polarized light or elliptical polarized light, the only case that in circularly polarized light we have the amplitude of both wave equal. In this case we have amplitude of non-equal amplitude of both the waves combining, but phase difference will be pi by 2 because pi by 2 is here also. If phase difference will be uh, like pi, then again this will be a only linear polarized light. Okay, pi or 2 pi. So whatever, so the circular polarized light is the special case of elliptical polarized light when we have equal amplitude. Okay, but we read circular polarized light पहले, उसके बाद we read elliptical polarized light. Okay, in elliptical polarized light also we have two case, left circular polarized and right circular polarized. Okay, so I have briefly discussed what is linearly polarized light, what is circularly polarized light, and what is elliptical polarized light. Okay, so next the thing will be, maybe sir have not discussed because I also did not saw the video, I just saw the topics which are covered in this one. How to generate these polarization. Okay, that will be our next topic. So till here I only just show you the mathematical representation, like the wave equation we know, we have this thing, the wave equation, something like that, and if we have some particular direction of that wave and we adding these two waves, then what happens, how the polarization will change, like that. But this is all mathematical. How we will do it with we can say experimentally, like you are in lab and I am saying you just generate the what I can say, just generate circular polarized light. We need circular polarized light in our experiment. Then how will you generate? Do you have some answer of this? So do you know how to generate all these things in experimentally? Respond something. Okay, so there are some particular ways to generate the polarized light. Very simple way is, we know the reflection, right? So from reflection also we can generate a polarized light. Okay, and some bifringe material are also find. Bifringe. If you find difficulty, I will explain all these things. but today it has 7:53. So maybe in next class I can explain, or just see search video. If you have some doubt, you can ask me. Okay, but I will just brief today for whatever we can discuss to in next class. But you can just study about these terms. This bifringe material. So in bifringe material, what is the special thing is this one. Uh, this material is such that the refractive index in this direction we can say NO, and refractive index in this direction I can say NE is different. Okay, so in some direction the light is slow, in some direction light will be fast compared to this one, not the faster than our air medium. This will be faster in one direction, slower in this one direction. So whatever the direction is slower, okay, so these crystal can pass with some particular vibration or particular direction of vibration, it can pass through. Okay, so from using this bifringe material we can make a polarizer. Okay, so one thing is this thing, bifringe crystal in this part will come, and you have seen calcite crystal. Have you heard about this? So this crystal is also very famous in polarizer chapter, because in this one, this optic axis, one will be optic axis, one is non-optic axis. So along the optic axis this ray move fast, and it also gives us in some polarization. Okay, so this bifringens is one phenomena in which we can use to the bifringes property we use of these materials to show the polarization. Okay, and about the polarization you can find of every material. Like for glass, the critical angle is around 54 or something. If you false that light greater than 54, the light will be linearly polarized from unpolarized. Okay, so you just read about these things and you can ask in the next question, next class. Okay, so and another property is dichroism. Okay, from which we use to make a polarizer. So the polarizer will be like that. Like if we pass some crystal, so there is all direction of polarizer of the light is there, and it will pass through only one direction of polarization. So this convert as a polarizer. So how we'll find that the light? How can we recognize that light is polarized or not? So for that we can perform only simple experiment. Experiment will be like that. There will be some light here. Just I am showing with the plane, and we put one polarizer. Okay, so here the all direction of vibration will be there, but after that only one direction of vibration will be there. So this is polarizer which polarize in vertical direction. The axis of this polarizer is this one. Okay, so this pass only this type of vibration. Then we show here the detector. Okay, so if light will be there I naught, so here will be I naught by 2 generally. It comes from Malus law actually. Okay, similarly if we recognize which polarization is coming, we put another polarizer on the way of detector, and we rotate this and set such that the polarization axis will be this one. So it will block completely of this polarization light. Okay, because it is the direction is perpendicular to this. So here will be comes E equal to 0, means detector found the zero intensity. then we can say that there is only one direction polarization light, that is linear polarized light, and if we rotate it in this direction, this is rotatable, okay, and when the axis will match, the I will be max. I max means it will be equal to I not equal to 0, because from unpolarized light to polarized light, intensity comes to half generally, and at this it will only half if there is no absorption by this polarizer. Okay, we consider. So do you get this? How we can find the experimentally that light is linearly polarized or not? Okay, so if I give you two polarizer, you can very clearly perform this experiment to see light is linearly polarized or not. Okay, and if there is unpolarized light, you will rotate this polarizer, intensity will not change if there is only one polarizer, because in unpolarized light there will be all direction of vector. So whatever axis will match for the one polarizer, it will come to that one. So intensity will not change once the polarizer is there. Okay, but if we put some another polarizer, then intensity will go from 0 to maximum. Okay, so in this way we can find that there is a linear polarized light. Okay, so can we stop here for today, or do you have any question from your side? Hello, can we stop here?
Yes.
Yeah.
Yes, sir. Yes, sir.
So in next class we will solve the assignment of third week from this week first, and then we will go similarly from this class the fourth week, whatever sir have taught you, I will explain in topic wise in very brief. Okay.
Okay, sir.
Okay. So bye from now and take care.